Have you ever watched a robot arm at work? It moves with a smooth, perfect motion that seems almost magical, like something from a science fiction movie. It can repeat the exact same task thousands of times in a row without ever making a mistake. How is that even possible? You can see these amazing arms in giant car factories, lifting heavy frames and welding metal together in a shower of sparks. They are also used to assemble our favorite electronics, placing tiny components onto a circuit board, components smaller than a single grain of rice. Incredibly, some of the most advanced robot arms are now found in hospitals, helping surgeons perform delicate operations with superhuman steadiness. From building a car to helping save a life, they perform every job with the same unbelievable precision. But it's not magic. It's just brilliant engineering. Think about trying to do that with your own arm. You can easily pick up a glass of water, but could you put it down in the exact same spot, down to the millimeter, 100 times? You would probably find it almost impossible. Your muscles get tired, your hand might shake a little, and your mind can get distracted. A great challenge for engineers was to design and build an arm that could overcome all of these natural human limitations. To accomplish this, they had to break down the idea of movement into simple, logical, and perfectly controllable parts. First, every robot arm needs a skeleton. These are its joints, and they work a lot like your shoulder, your elbow, and your wrist. Each joint allows the arm to move in a very specific way, such as rotating from side to side or bending up and down. Engineers call these individual movements degrees of freedom. The more joints you have, the more ways you can move. A typical advanced robot arm has 6 joints, giving it 6 degrees of freedom. This allows it to reach almost any point in the space around it, from any angle. This complex system of joints is what gives the robot its incredible flexibility to twist, turn, and reach around objects. But those joints can't move on their own. They need muscles to drive them. For a robot, these muscles are called actuators. In most robot arms, the actuators are powerful and highly precise electric motors, with one motor dedicated to each joint. When the robot's brain sends an electrical signal to a motor, it spins a specific amount, causing its connected joint to bend or rotate. Unlike our muscles, these motors never get tired. They can provide the exact same amount of force and speed every single time, all day long. This is where the robot gets its tireless strength and its perfectly consistent motion, which are impossible for a human to match. So we have the bones and the muscles. But how does the robot know the exact position of its arm? It needs a sense of awareness. This critical job is performed by sensors, which act like the robot's own nervous system, constantly sending information back to its brain. The most important sensors for motion are called encoders. These tiny devices are attached to each motor and measure its rotation with incredible accuracy. By constantly reading the data from every encoder, the robot's brain knows the exact angle of every single joint at all times. Finally, all of this hardware needs a brain to control it. This is the robot's computer and the software that runs on it. The programmer gives the robot a set of instructions, telling it exactly where to go using coordinates, almost like a destination on a digital map. The program is essentially a recipe for movement. Move your gripper to point A, close the gripper, then move to point B and open the gripper. The robot's brain takes that simple command and calculates the exact angle that each of its 6 joints needs to be at to reach that precise point in space. It then sends the perfect amount of electricity to each motor, and it doesn't stop until the sensors report back that the arm has arrived at the correct position. That is the real secret behind the robot's flawless precision. It's a constant, high-speed conversation between the brain, the motors, and the sensors. The brain gives an order. The motors execute the move. The sensors report back on the result. This is known as a closed-loop control system. The robot isn't thinking or improvising the way a person does. It is simply and perfectly executing a detailed plan it was given. Its greatest advantage is that it is a specialist. It never gets bored with repetition, it never gets creative, and it never, ever gets distracted from its one job. So a robot arm is much more than just one piece of technology. It's a whole team of different systems all working together in perfect harmony. The skeleton provides the structure, the motors provide the power, the sensors provide the awareness, and the code provides the ultimate plan. It shows that even the most complex challenges, like creating perfect, repeatable motion, can be solved by breaking them down into simple, understandable parts.